Alright, so here we have question 6 of the November 2018 grade 12 math exam of the CAP system in South Africa. And question 6 is another functions of graphs question. So let's just get into it. In the diagram below, A and B are the x-intercepts of the graph of f, and they give us the equation of the parabola. They tell us that a straight line G, this one here, cuts the graph of the parabola at C, and the y-axis at 0, 1, right there. Now M is a point on F, and and N is a point on G, such that MN is parallel to the y-axis. So this is a vertical line here, and MN cuts the x-axis at T. Okay, so everything is given in the picture. Now show that g of x equals x plus 1. Okay, so g of x, let's do 6.1 here. So g of x, we know that's a straight line, right? G of x, and what is a straight line equation? Mx plus c. Alright, so what we need to do is we need to find m and c. Now, m is our gradient and c is our y-intercept. So already we know the y-intercept. Y-intercept is at 0, 1. So far we know it's y, or g of x, equals mx plus 1. Right, we can read that off. And now we need to find the gradient, or find m. Now one thing we could do is we could just use these 2 points that we have and calculate the gradient. So if we were to do that, it would look like this. We have one point, we've got c, and we've got the point, well, c is 4, 5, and we've also got the point 0, 1. Now we can just say m equals the change in y over change in x. So 5 minus 1, change in the y values, divided by 4 minus 0, the change in x values. And that gives us 4 over 4, which is 1. So we know m is going to be 1. Another way we can do it is we already got the 1 point, so we can just substitute another point in. So if we just, into this equation, if we just substitute the point 4, 5 into this equation, we'll also find m. So that would look like this. 5 goes in the y, mx is 4 plus 1. So we get 5 equals 4m plus 1. Take the 1 over, so 4 equals 4m, and divide both sides by 4, and 1 equals m. So 2 ways we can do that. Okay, and it doesn't matter which one you choose, either one is fine. And then finally, we'll just say, therefore, g of x equals 1x plus 1. Right, and that's what we had to prove, or had to show. Great, let's get on to question 6.2. 6.2, calculate the coordinates of A and B. So those are the x-intercepts of the parabola. Now here we have the equation of that parabola. And to find x-intercepts, we need to let y equal 0. So to find an x-intercept, we say y is 0. So we're just going to replace the y with a 0. So we're going to say 0 equals x squared minus 2x minus 3. X squared minus 2x minus 3. Right, now how do we solve this? Well, this is a quadratic equation, so we've got many different ways of solving it. I'm going to see if this can factorize. So if it can factorize, we're going to have 2 brackets. We're going to have x times x, which will give us x squared. And now the factors of 3 are 1 and 3, right? So if we have minus 3 and plus 1, then we'll get a minus 2 in the middle. Minus 3 times positive 1 is minus 3. So this is correct. And then we can get x equals 3 or x equals negative 1. So those are the x values of A and B, and the y values are 0. So A, what will be the coordinates of A? Well, A is on the left hand side. A must be a negative x value, right? So A will be the negative 1. So A is negative 1, 0, and B will be the other one. So B will be 3, 0. 3, 0. Alright. Now, next color for the next question. 6.3. 6.3. Determine the range of f. So what does it mean to determine a range? A range is all the outputs that can arise from a certain function. So the range, all the y values for which this graph exists. We see this graph exists everywhere above this line, right? Above this value for y. Everything above that, the graph exists. Below this, the graph does not exist. So what we need to find is then this y value at the turning point here. So to find the turning point, again, many ways we can do that. One way to find the turning point is we can say the x value of the turning point of a parabola is negative b over 2a. And this will get us x equals, what is the b value? Negative 2, right? So negative 2 over 2 times a. And that gives us positive 2 over 2, which is 1. So we know the x value here is 1. And then to find the y value, we just substitute this back. So y equals 1 squared minus 2 times 1 minus 3. So y equals 1 minus 2, which is negative 1, minus 3 is negative 4. So then this point here is 1 and negative 4. Okay, so what does this graph exist? Everywhere above y equals negative 4. So we're going to say y, all the y values for which the graph exists, is everything greater or equal to negative 4. That is the range. Great. Now another way we could find the turning point is we know the x value of the turning point of a parabola is halfway between the x-intercepts. So if we know the one intercept was negative 1 and the other one was 3, then we could just say let's find halfway between negative 1 and 3. That'll give us 2 over 2, which is 1. So again, we find 1. Another way we can do it is we can use completing the square to find it, to write the equation in this form. Y equals a, x plus b squared plus q. So there's a whole process of completing a square to get to this step. And once we are here, we can read off the turning point. So the turning point will be negative p and q. So in this case, this value would be a negative 4. So we'd say y is greater or equal to negative 4 for the range. And one more way that we can find the turning point is to say the gradient at this point, at the turning point, is 0, right? It's a flat line, horizontal line. So when is gradient 0? Well, to find the gradient of 0, we differentiate the original function. So if we differentiate x squared minus 2x minus 3, so that would be f prime of x, differentiate that, we'll get 2x minus 2. And if we put that equal to 0, so where the gradient is 0, then we'll get 2 equals 2x, and again we'll get x equals 1. Right, so that's again the x value of the turning point. Substitute that back in to find the y value. So those are all the ways that I think we should know how to find the value of the turning point. Alright, good, so that was the range. Now, next question, 6.4. 6.4. If mn is 6, so this distance here, if that distance is 6, then 6.4.1, determine the length of OT, so this one here, if t lies on the negative x-axis. Okay, so this is fine, just like the picture shows, and show all our working. Okay, let's see, how will we get that? Well, mn is 6, and what is mn? Well, that's the distance, the horizontal distance between f and g. So that's the y value of f minus the y value of g. So we can just say f minus g. Alright. So mn, the distance mn is equal to f minus g. Alright, so f is x squared minus 2x minus 3. Now we're going to minus the g of x from that. And gx is x plus 1. So minus the x plus 1. And remember your brackets. Alright, let's simplify this a little bit. So x squared minus 2x minus x is minus 3x. And then minus 3 minus 1 is minus 4. Okay, so that's mn. And we're told that mn is 6. Okay, so then we can find the x value here by solving for x now. So it's a quadratic, so we take everything to one side equals 0. X squared minus 3x, and then negative 4 minus 6 is minus 12. Minus 10. Sorry. Alright. So that is our equation. Now we need to solve that. Okay, so this one again can factorize. We're going to have two brackets. We're going to have an x and an x will give us x squared. Now factors of 10 that'll give us a 3 if we add them will be 5 and 2. So negative 5 and positive 2. And sorry for that. So now we can say this equals 0 or this equals 0. So we get x equals 5 or x equals -2. And what did they say here? On the negative x-axis, right? So we need to use this one. Okay, so x value is -2 here. So that's -2. Now if the coordinates of t, let's just write that down. So let's say this means that the coordinates of t are -2, 0. And we need to find the distance OT. So OT, we know O is 0, 0. So what is the distance between these two? Well, you can use the distance formula, but obviously it's a flat line, horizontal line. So because these values are exactly the same, we can just say what's the difference between -2 and 0? Well, the distance there would be 2, right? From -2 to 0. And let's just plug it into our distance formula just to see that it works out to the same thing. We could also say, let's say or OT equals distance formula, which is just Pythagoras. Difference between the x values squared, so -2 minus 0, -2 minus 0 squared, plus difference between the y values squared, 0 minus 0 squared. Yes, so then we get the square root of, so -2 minus 0 is -2, -2 squared is 4. Right, 0 minus 0 is 0, 0 squared is 0. So we get square root of 4, which is 2. Now it's plus or minus, but distance is only a positive value, right? You can't have a distance of less than 0. So it is only the positive one we're looking at. So that's why we say 2. And now 6.4.2, let me do that over here. 6.4.2 ends right on the coordinates of n. The coordinates of n. So we already know what the x value is, and we need to find the y value, right? But n is on G. So far for n we know the x value. We know it's -2, and the y value we don't know yet. But we know it lies on the graph of G, so we can substitute it into G. Right, so g of x, let's just write that out again. G of x is x plus 1. But we know the x value, so we can work out the y value. We can say y equals x, which is -2, plus 1. So y equals -1. And therefore, n is -2 and -1. There we go, coordinates for n. Great. 6.5, sort of getting there towards the end now. 6.5. Determine the equation of the tangent to f drawn parallel to G. Okay, let's do that over here. 6.5. Okay, tangent of f parallel to G. Let's actually just see what that would look like. So if we draw this line, and now I'm just going to move it. Actually, I'm going to draw it a little bit shorter. That should be better and easier. Just a shorter line here. And now let's move this one. Okay, so it must be a tangent to f. So that'll be, looks like over here, right? Over here it'll make a tangent. Let's do it right there. Okay. So we need to calculate the equation of this line. So it's a tangent to f parallel to G. Right, we can see it's parallel, so we just drew it right there. So it's parallel, and so we need to find the equation of this line. So what we need to do is we know the gradient of this line. Let's start with that. Right, it's parallel to G, so it has the same gradient. So far we know the tangent we're looking for has a gradient of 1. So 1x plus c. Now to find c we need a point. And we don't have a point, right? Over here. We don't have any point on this line, so we can't just substitute in. So what we need to do is we need to find out, well, where is the gradient of the curve also 1? Because the gradient of f and the gradient of this line here will be exactly the same at the point where they touch, right? So how do we find the gradient of a curve? Well, we differentiate. So we need to differentiate. So f prime of x is when we differentiate. Let me actually just write out f of x first, just so we can see. So f of x was x squared minus 2x minus 3. Now if we differentiate that to find the gradient, we get 2x minus 2. And we'll work through how to differentiate at another stage. Let me just show you the basic idea. If we've got ax to the power n and we want to differentiate this, so we differentiate, Then what happens, we take this exponent, multiply it in the front, and then we just subtract 1 from the exponent, right? So here we just say 2 times 1 is 2, x, and then 2 minus 1 is 1. So that's all we do here. Right. So that's the gradient of f. Now we want to find the gradient, or we know the gradient must be 1 over here. So to find this x value, we can just say the gradient is 1 over here, because that's the same as this line. The gradient is 1. Let's find out what x is. Okay, take the 2 over, so we get 3 equals 2x, and then 3 over 2 equals x. So that's the x value over here. So 3 over 2. And then we still need to find the y value. Okay, to find the y value, we can just substitute this back into our equation, into our parabola equation. So y equals x squared minus 2x minus 3. So y equals 9 over 4 minus 3 minus 3. So 9 over 4 minus 6. I mean, this is probably just calculator work. And 6 is the same as 24 over 4. So y equals 9 minus 24 is what? Negative 15 over 4. So that's the y value. Negative 15 over 4. Alright, so now we have a point. And we can substitute that point into our tangent equation to find the c value. So let's do that. Okay, so y equals x, and x we know is 3 over 2, right? So let's just highlight that, 3 over 2, and that's the y value. So x is 3 over 2 plus c, and now we can solve for c. Okay, so negative 15 over 4 minus 3 over 2, which is the same as 6 over 4, equals c. The negative 15 minus 6 is negative 21 over 4. So then finally our equation for our tangent is y equals, we know it's 1x plus c, so y equals 1x plus c, and c is negative 21 over 4. And there we have the equation of our tangent. So the important thing to remember here is that, let me actually just draw a sketch. If you have some sort of a function and you've got a tangent at some spot, let's say that's a tangent there. So at this point right here where they touch, the gradient of the tangent and the gradient of the curve are exactly the same. So you can use that either way around. If you know the gradient of the straight line, you can find where this point is by saying the gradient of the curve has the same gradient as the tangent over there, and then that you can use to find x. Or the other way around. If you know what the gradient, we already calculated the gradient of the curve, and you know this point is, let's say, 2, then you can find the gradient at 2 for this curve, and you know that's going to be the same as the gradient for this straight line. So that's very useful in a lot of questions. Right, what do we have left? Okay, one more question. For which values of k, let's look at the picture here. So for which values of k will fx and hx, and the hx we know is x plus k, not intersect? So not to intersect means you don't have a solution when you set them equal to each other, right? Because they don't intersect. So let's do that. What color? Let's do that in black. Okay, so let's just rewrite the equations. So fx equals x squared minus 2x minus 3, and hx, that tells us, is x plus k. So they're asking for which values of k will these two not intersect. So again, to not intersect means it has no solution when you set them equal to each other, because they're never equal, they never intersect. Okay, so let's set them equal to start with, and then find when that is an error. Okay, so x squared minus 2x minus 3 equals x plus k. So this equation must have no solutions. Okay, so we see it's quadratic, so take everything to one side. Minus 2x minus x. We can probably simplify that. So minus 2x minus x is minus 3x. And then minus 3 minus k. Minus 3 minus k equals 0. So we need to find where does this have no solutions. Right. So we know it's gonna have no solutions, so we can see for which values of k will it have no solutions. Okay, so to not have a solution, well, we know in the formula x equals negative b plus minus square root of b squared minus 4ac all over 2a. Obviously, if this thing is negative, we won't have an answer, right? We can't have a square root of a negative number. So we want to say b squared minus 4ac, if that's less than 0, this thing will have no solutions. Okay, so let's plug the values in. So what is b in this case? Negative 3, right? The value in front of the x. So negative 3 squared minus 4 times a, which is 1, times c, which is negative 3 minus k. Negative 3 minus k must be less than 0. I'll just rewrite that a little bit better. Negative 3 minus k. Alright, so negative 3 squared is 9. Minus 4 times minus 3, so we can ignore the 1. Right? Minus 4 times minus 3 is plus 12. And then minus 4 times minus k is plus 4k, less than 0. Okay, so now we've got 4k less than 9 plus 12 is 21, so we take that over to negative 21 and divide by 4. So k is less than negative 21 over 4. Alright, so that's a long way to do this question. There was a shorter way to do it using the previous answer, but I think this is good to know, good to look at. Right, so the shorter way to do it would be to see that x plus k, this gradient here is 1, right? And this gradient is 1 for this tangent that we had. So let's just look at this. If we move this tangent, let me actually just select it like that. So if we move this tangent at all, right, anything down, so let's look at it like that. So now we can see at the moment, I think I just made everything go away. Let's just, okay, there it's back. Oh, not. Oh, so bad at this. Let me just highlight them. And let's say do something like that. Okay, now it should be back. Okay. Right. So if we take this line, we know that at this point here, where the tangent touches the graph, we know the y-intercept was negative 21 over 4, right? So that's this value. So if we move this graph down at all, why do I keep getting that wrong? Sorry. Let me just highlight that again. Okay, so if we move this tangent graph down any at all, right? If we move it down, it no longer touches because it's a tangent. There's no other place it'll touch. And if we move it down, this value becomes less than negative 21 over 4. And that is the value of k here, right? So if this thing is smaller than negative 21 over 4, then the graph with the line with this gradient will no longer touch the graph. So if you saw that, that's nice. You could do that for 1 point. But I think some people would not see that, and hence we'll have to go through this process. Just putting them equal to each other and saying that delta, we also call this whole thing delta, must be less than 0 for it to have no real roots. Alright, I hope that was helpful. If you have any questions, please leave them in the comments below. I know some of these questions can be a little bit tricky. Please leave some questions, or if you found alternate methods to do any of the questions, please let me know. It's always great to find new methods or different methods of doing things. And that's the great thing about math. Some teachers teach some methods and others teach other methods, and then we can learn from each other. Alright, I hope this was useful, and I'll see you again for the next question, question 7.